Hello viewers, today we will see how to identify entropy using Python script. I'm going to use Spider on Anaconda IDE, Islam. What is entropy? There are so many resources. You can learn about entropy. But those of you who studied physics in school, you know entropy is all about hidden energy. So it's a measurement of uncertainty or randomness. When it comes to image processing, there are many different applications. When it comes to image processing, it is about statistical measurement of randomness. In plain English, it is about identifying the hidden energy on images. Definition of hidden energy on images works differently. There are so many resources you can Google and you can learn from there. But roughly through an entity, we can do some sort of segmentation. It can be part of segmentation. And also entropy can help us highlighting informations from which we can derive pattern, or we can measure ages and ratios and so many other things, segments and so many. This is the formula for entropy. It is not the major focus in today's video. Feel free to do research at your own and if you want to learn more. This is one of the entropy picture. As we can see the original picture and the entropy picture, it shows the energy flow and it gives some sort of outline. If we filter it, it can become more clear. I got these pictures from this website, Scikit-learn. Feel free to come to this site and read more. And there are some sample coding in this section too. Let's see how we can find out entropy in today's video. Then it might become more clear to us. First thing that always I do, I want to make sure what my directory is. If the directory is not correct, then I need to make sure the location where my objects are, that location is pointed. If not, at the beginning we should point it. And to do that, so I have it until this folder. Alternatively, I can see my directory here too. Getting the correct libraries. Today I'm going to import data through CV2. CV2 is part of OpenCV in Python. And the benefit of CV2 has so many features embedded that helps us in image processing, and we can manipulate the image in so many different ways. And CV2 help us importing data as it is without making any changes. There are other methods you can use, but the target is we have to import the image as on grayscale. We have to make sure that it is a two-dimensional array. As long as it is two-dimensional array, we are able to process the entropy of images. If you do not have CV2 installed, you can pip Python. I should have that installed. Let's see if I have. I'll get an error message if it is not. CV2 OpenCV installed. If you want to pip it, it might give you an error message. Don't worry, just run it. This will still run. I have it already, so I'm not going to run it again. Few more libraries I need. Matplotlib, always that is very useful. I'm going to use pyplot. From SciImage, I need few libraries. I need to bring entropy first. What else I need? I need disk. And I need ubyte. Again for SciImage, ubyte is unassigned integer. And that is going to be, you can also do float. That is going to be my image array data format. Let me make sure this library works good. I'm able to import this library successfully. Now I need to import the data first. Let's import both gray and color format. So let's call it the first. Well, let's call it image1 because I'm going to use images, and this is a satellite data, so I'm going to import this data, and I know it's JPEG format. Images folder format is JPEG, and I'm going to import it as gray. 0 is gray, 1 is color. Yes, it got imported. Let me import the color format too, so we can see side by side. Let me call this image2. This one is 1, and let's see the image now. CV, going to show it, and let me use level, differentiate which one is what. This image 1, and something I did not do right. Okay. This will be color image. Still something is not right. Undefined CV, yeah, CV2, CV2. I'm going to use a destroy switch, otherwise it's gonna keep running on and on. First of all, let me add a wait key, and I'll put 0 so that I can kill it whenever I want. So all windows will be destroyed once it runs. Okay, now let me run. Don't see any error. CV2 has no attribute show. Actually, it should be I am show, not only show. I am show. Okay, so these are my images. So this is the original. This is the original image. This is the color image I just imported. This is the gray image I just imported. Let me close the original one. The original one and the color image looks same. This is one of the benefit in CV2. You don't have to correct BGR to RGB. It imports the image as it is. Now, in our today's video, color image is not of our interest. So let's not worry about that. Let me just make sure my color is 2D. Otherwise, the entropy will not work. So image D dimension. Let me check the dimension of the image. The dimension is 2. So this is ready for entropy analysis. This is the stage when you're going to bring entropy on the image. Let's assign the value 10 in the disk. Entropy image, and something is wrong. Entropy disk, okay, typo disk, and it's all good. Let's see the entropy image now. Just this one line of code, and it will do all the math, and it will bring the entropy on the image. This is what it is. Let me show it in a bigger window. This is the entropy it looks like. It looks blurry. Now there are other filters we can use to make it more prominent, but that's not the goal today. As we can see, the aspect ratio wise, this section is compatible. This one was the water section. This did not do a good job capturing the filter. This color and this color should be the same. We can add more filter to correct it, but I'm not going to go through those details. The edges are a little blurry. The best way to measure the edges based on entropy image, if we can convert them into binary image. So let's do a binary image now. Basically, it's a binary segmentation of the image. So the edges are clear, more clear, and we are able to calculate the edges. And to do binary image, we have to first of all calculate threshold. There are multiple methods of calculating threshold, but I'm going to use Otsu threshold. Feel free to Google to read about what Otsu is. But there are so many YouTube videos I have seen. Basically, people spoke about different kind of threshold analysis, mean, Otsu, and there are many. Let me import threshold, Otsu threshold, Otsu. This should calculate the threshold. Entropy image 1. And threshold has been calculated. Let me see the threshold value. So 4.0945, this is our threshold. Our binary value needs to be below that threshold. So what will we do? Below or equal binary entropy image 1 threshold, it needs to be below, and then we plot always I am show What are you gonna plot? We're gonna plot binary. And let's see. So when we do binary, we can see the edges are way sharper than the edges here. All the different edges. Now we can filter them and we can improve them. There's supposed to be another one here, which is not. So it's not the fault of the binary, it's because when we did entropy calculation, we needed to add more filters here. And that's all for today. I wanted to show how does it looks when we map the entropy on our images.